Namaskar. Welcome in this lecture series on software engineering fundamental. Uh, this is Dr. Bright Keswani, professor in computer science and engineering in Suresh and Vihar University, Jaipur. In today's lecture, we will discuss about software design fundamentals. These are some objectives, learning objectives and learning outcomes of this lecture. Through this lecture, you will learn about the basic principles of software design and how to make your software design more effective and qualitative. The expected learning outcomes are the first outcome that you will be understand after this lecture, the aim and objectives of software design, and secondly, how to easily resolve complex problem through effective software design. So these are the learning objectives and learning outcomes of this lecture. This is the agenda of the lecture: to learn about introduction to software design, purpose of software design problem solving techniques, software design models, and after the learning about software design models, we will discuss about software design strategies. Then we will discuss about software design process failure and remedies, and at last we will discuss about good design versus bad design. So let us start about this important activity of software development, which is software design. So as you know that software design is a very large activity. It is one of the very large activity of and crucial also to design complex software, because most of the errors occur due to the poor designing. So it is a very crucial activity, you can say, and as defined by the Code and Yarden, software design is a process to transform user requirements into some suitable form, which helps the programmer in software coding and implementation. For assessing user requirements, an SRS means software requirement specification document is created, whereas for coding and implementation, there is a need of more specific and detailed requirements in software terms. The output of this process can directly be used into implementation in programming languages. Software design is the first step, you can say, of the SDLC, which moves the concentration from problem domain to solution domain, and it tries to specify how to fulfill the requirements mentioned in SRS. As you know that SRS is an important document, and the design and SRS provides a basic framework for software design. So what is needed? The proper design is needed. The proper strategy of designing of software is needed as per the user requirement, so that we can provide the document and design document to the user and to the developer. Software design is the practice of taking a specification of externally observable behavior and adding details needed for actual computer system implementation, including human interaction, task management, and data management details. So, Core suggested that the software design is considered as a process to transform user requirements into some suitable forms, and it helps to the programmers in software coding and implementation. As per the other definitions, software design is the process of inventing and selecting program that meet the objectives for a software system. So the input includes an understanding of the requirements, understanding about the environmental limitations, and understanding about the design criteria. So three things are important, and they are, you can say, they are working as input for the when we are going to design the software. First is requirements. Understanding about the requirement is very much needed to design proper design software. Then requirement, environmental limitations, you should know about them. And then design criteria. Criteria should be known to you, so that you can make a better design. Some outputs are expected from the designing activity. First thing is architecture design, which shows how units are interrelated. So first thing is architectural design is the you can expect as an outcome from the system. Then specification for new units. You can generate, you can develop the specifications for new units. And thirdly, definitions for any new data. If any new data is added at the customer's point of view, then you can define all the new data which in the design specification document. So, nut and shell, we can say that software design is the activity of specifying the nature and composition of a software system, satisfying client needs and desires subject to design limitations. Okay, so you can say that design is an important, software design is a mechanism to transform user requirements into some suitable form, which helps the programmer in software coding and implementation. And it deals with representing the client's requirements as described in the software requirement specification document into a form that is easily implementable using programming languages. So as you know that the next phases of the SDLC is coding. So coding is based on the proper designing. So design document is created, is developed in this activity as an output, and it will be given to the programmer, and through the proper understanding, through the proper study of design document, a programmer can develop his program as per the design specification given in the design document. So the software design document is the first step in SDLC, which moves the concentration from the problem domain to the solution domain. So you can say it is the first activity of SDLC, which moves the concentration from the problem domain to the solution domain. Now we are working towards the solution domain. In software design, we consider the system to be a set of components or modules which clearly defined behaviors and boundaries. So you can not only provide the solution, you can you not only provide the, being a designer, you not only provide the single solution of a particular problem, you should provide multiple solutions to a single problem, and you should suggest the appropriate solution also to the particular problem. Okay, so concepts are defined as a principal idea or innovation that comes in our mind or in thoughts to understand something. The software design concept simply means the idea or principle behind the design, and it describes how you plan to solve this problem of designing software, designing the logic or the thinking behind how you will design software. It furthermore, it allows the software designer and software engineer, you can say the software architect, to create the model of the system or software or product that is to be developed or built. The software design concept provides a supporting and essential structure or model for developing the right software. It is very much important. And there are many concepts of software design, like abstraction is there, like uh, refactoring is there, information hiding is there. These all are the software design concept. Modularity is the important concept of software design. Then architecture, appropriate architecture, redefining, refining, refactoring, and pattern are the information hiding are the uh, software design, some of the software design concepts. So let us discuss all the design concepts one by one. The following points should be considered while designing a software. First is abstraction, means hide relevant data. It is called abstraction. Abstraction is general problem solving technique of particular importance in design. And in this technique, some details of a thing are ignored in favor of others. So you already aware about the abstraction. The first, ignoring non-essential aspect of a problem, simplifies it and makes the problem easier to solve. So what is the purpose of abstraction? To ignore the non-essential aspect of the problem and simplify the problem. The second important use of abstraction in designing is as a means of structuring design problem solving. Okay, and the third important use of abstraction in design is as the basis for modeling. So abstractions provide you the basis for modeling, and it hide all the non-essential details. Okay, so what is abstraction? Abstraction simply means to hide the details to reduce the complexity, and it increases efficiency or quality. So different level of abstractions are necessary and must be applied to each stage of the design process, so that any error that is present can be removed to increase the efficiency of the software solution and to refine the software solution. The solution should be described in broad ways that cover a wide range of different things at a higher level of abstraction, and a more detailed description of a solution of software should be given at the lower level of abstraction. So abstraction is an important important characteristic which is to be followed by the while designing the software. Second is modularity. Uh, 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 you can make your system as a modular system. You can divide several systems in several units. So modularity simply means to divide the system or project into smaller parts to reduce the complexity of the system or project. In the same way, modularity in design means to subdivide a system into smaller parts so that these parts can be created independently, and then use these parts in different systems to perform different functions. And it is necessary to divide the software into components known as modules, because nowadays there are different softwares available, and engineers are using different type of softwares, and they are using different type of modularity. So modularity is design uh, uh, has now becomes a trend, and it is also an important component. We should important uh, concept we should adopt while designing a software. The third one is architecture, designing a structure of something. So architecture simply means a technique to design a structure of something. Something means what? Means software. Okay, here we elaborate the word something means what? The software. So architecture is designing software is a concept that focuses on various elements and the data of the structure, and these components interact with each other and use the data of the structure in architecture. When we talk about refinement, refinement means remove the impurities. So it means refining something to remove the impurities if present and increase the quality. The refinement concept of software design is actually a process of developing or presenting the software or system in a detailed manner. That means to elaborate a system or software. Refinement is very necessary to find out any error if present and then to reduce it. So refinement is the another important component of any quality software design. Then patterns. Patterns are repeated form. The pattern simply means a repeated form or design in which the same shape is repeated several times to form a pattern. So pattern means a repeated form. Okay. The pattern in the design process means the repetition of a solution to a common recurring problem within a certain context. So refinement and redesigning and repetition is necessary are some necessary components of a good software design. So pattern is also a part of good software design. Then information hiding, hide the information. Information hiding means to hide the information so that it cannot be assessed by an unwanted party. So in software design, information hiding is achieved by designing the modules in a manner that the information gathered or contained in one module is hidden and it cannot be accessed by any other module. So information hiding is the another important concept when we are making a good software design or quality software designing. Then refactoring. Let us discuss about refactoring. Means reconstruct something. Uh, means construct something in such a way that it does not affect the behavior or any other features. Okay, so that is called as refactoring, means restructuring, and restructuring in such a manner that do not affect the behavior of other modules or other feature. Okay, so refactoring is in software designing means to reconstruct the design to reduce the complexity and simplicity it and simplify it without affecting the behavior of its functions. Okay, so what is required? Refactoring is required. What is required? Information hiding is required. Patterns are required. Refinement are required, and abstraction, modularity, and architectures are required, uh, which is the software design, quality software design concepts. Okay, now the purpose of software design. What is the purpose of software design? How to design a software? It is a very important thing. There are several purposes like correctness, to make your software correct, to make your software complete, to make your software efficient, to make your software flexible, to make your software maintainable and consistent. So these are the purpose of software design. Okay, correctness means software design should be correct as per the requirement of the client. Okay, so this is the first purpose. Second is completeness. The design should have all components like data structure, module, and external interfaces. Third purpose is to make your software efficient. So resources should be used efficiently by the program. That is the purpose of design. The next purpose is to make your software flexible. Means the software will be able to modify on changing needs. When user change his requirements frequently, then there should be a flexibility in the system or flexibility in the software, that you should uh, you can able to modify the changing needs. Okay, you should you can incorporate the changing need of the client. Okay, so this is the means of flexibility. Then consistency. There should not be any consistency in the design, which is a very important objective of the software design. Then maintainability. The design should be so simple, so so that it can be easily maintainable by other designers. So we can easily so because of the design, software is maintainable. Because of the design, software proposed software will be efficiently work. And then completeness, it will be a complete software, it having the correctness characteristic. It possesses the correctness characteristic. Okay, so we can say that the purpose of software design to make a software as a quality software. Okay, or we can say that software design is a kind of problem solving. And thinking about design as a problem solving, there has many advantages. I elaborated earlier also that first it suggests that information may be partitioned between the problem and the solution. Okay, and second advantage of thinking about a design as a problem solving is the perspective it gives on the design activity. And the third advantage of thinking about design as a problem solving is that it suggests the use of time honored general problem solving technique in design. So uh, these are the purpose of problem purpose of software design, and I elaborated the uh, how why we thought that why we think about that software design is a problem solving technique. Okay, now come to the third point, uh, third issue of this third agenda of this lecture, that is software design problem solving technique. So some of the problem solving techniques applied to software design, these are the problem solving techniques, you can say. First is changing the technique, second is trial and error technique, then brainstorming technique, abstraction technique, and modeling in design. These are the you can say the software design problem solving techniques. Changing the problem technique means what? When a problem is too difficult, sometimes it can be changed, and client may be willing to modify their desires. So changing the problem technique is important. Trial and error technique means problem solving is an inherently iterative activity, and design should be too. Okay, so trial and error means uh, it should be error iterative activity, so that you can solve the problem easily. Then if you design the software, it is a brainstorming technique. Okay, you not only come with a single solution, you have to provide the multiple solutions of or identify the multiple solutions to a single problem. Then abstraction technique. Abstraction is generally, I earlier said that it is a problem solving technique of particular importance in design, and this technique, some details of a things are ignored in favor of others. So some important problem solving technique in as abstraction, I earlier said that first ignoring all and non essential aspects of a problem to simplify it to make the problem easier to solve. And secondly, second important use of abstraction to design is as a means of structuring design problem solving. And third important use of abstraction and design is as the basis for modeling. Okay, now come to the last software design problem solving technique, that is modeling in design. A model is an entity used to represent another entity called the target. Okay, by establishing a correspondence between the parts or elements of the target and the parts or elements of the model, and correspondence between a relationship among the part or elements of a target and relationship among the parts or elements of the model. So if the design is problem solving, then clearly modeling is a central tool in all design disciplines, and models are especially useful in design in three ways. First is design problem analysis. Second is it is useful in design criteria and investigation. And thirdly, to design the document. So design document is important, uh, design problem analysis is important, and design creation and investigation is very much important. So these are the software design problem solving techniques. Now we will discuss about the software design models. There are basically two models of software for software design: static model and dynamic model. So you can say that software design problems and solutions are complex, and many aspects of software systems must be modeled. There are many kinds of modeling notations used in the software design, but we can we can divide all these notations into two general or basic two broad classes. First is static models, and second is dynamic model. When we talk about static model, these models represent aspects of software systems that do not change during the execution. Sometimes the aspect of software systems changed in the during the execution. So in the static model, it represents the aspect of software system that do not change during the execution, and generally these models represent the software components, their characteristics, and relationship between software components. So you can say the if you are giving the examples of a static model are of software design, then you can define the object and class diagrams, use case diagrams, data structure pictures, operation specifications, and implementation diagrams are the some types, you can say, types of static model. Then, when we talk about the dynamic model, these models show what happens during software execution. Uh, you can say some, you can give some examples of uh, dynamic model. Uh, you can talk about interaction diagrams, or state charts, or data flow diagrams, or decision tree, decision tables. Okay, so these are the some examples of dynamic model that shows what happens during the software execution. So there are basically two types of models. First is a static model uh, that do not change their execution, change during execution, and the dynamic models show what happens during the software execution. Okay, so in software design, models from both of these categories are used for problem analysis, design creation, and investigation, and uh, uh, design documentation also. Okay, so these models are helpful in problem analysis first, second is design creation and investigation, and lastly in the design document. Okay, let us discuss about the software design strategies. So the generally the software design is a problem solving activity, we can say, and a general problem solving strategy is comprises of the of these steps. The first is understand the problem. Second step is generate potential solution to the problem. The third step is evaluate the potential solution to pick up the best, and uh, uh, fourth, if the best solution are inadequate, return to step 2. Step 2 is general potential solutions to the problem. Then if the best solution you found is not inadequate for the specific problem, then return to the step 2 and generate the potential solution to the problem to refine solution to generate a new or generate the new solution. Then the last step is ensure that the solution is adequate and that the work is complete and well documented. So these are the steps. These are the strategy of software design, and strategy comprises into these steps, these 5 steps. Understanding the problem is the first step of this strategy, and ensure the solution. If solution found proper, then the work is complete and it should be documented. This is the design software design strategy. Let us discuss about the software design process. The software design process, there are several notations regarding the software design process. The first notation said that there are software design process have 2 levels. First is external design and second is internal design. The external design focuses on deciding which module are needed, their specifications, relationship, and interfaces among them. So the external design is one level, and the internal design is second level. Internal design is concerned with the focus on planning and specifying the internal structure and processing details. So there are two software designing levels as per the notation 1. Uh, as per the notation 2, the design is mainly decomposed into 3 levels. Okay, uh, what are these 3 levels? First is interface design, second is architecture design, and third is detail design. You can say you can see it in this diagram. Analyze the problem and document it, then generate the system interface. So interface design, generate the interface design and document it, and evaluate it. Okay, evaluate the system design. So generate the system interface and evaluate the system document. So when you document it here, then you should evaluate the system document, and again document it if any error found, or what you evaluated, what you have evaluated in the software design mention it in the yeah, system design interface design document. So if you not during evaluation, if you not found it proper, then generate the system design again, and this is the iteration uh, happen until you found the proper results. Okay, then if you found the proper result, generate the architecture or and document it, then evaluate the architecture, then document it. If you not found the architecture as per the specification, then generate the architecture again and document it, and it is again a iterative process. Otherwise, you should proceed further, generate the detailed design document and evaluate the detailed design document and review the design document. Okay, so this is the basically this is the uh, software design process as per the second notation. Okay, uh, so the first design activity is interface design. Interface design is the specification of the interaction between a system and its environment. This phase proceeds at a high level of abstraction with respect to the inner working of the system. That is, during interface design, the internal of the system are completely ignored and the system is treated as a black box. Attention is focused on the dialogues between the target system and the users and the devices and the other systems. Okay, so the design problem statement produced during the problem analysis step should identify the people, other system, and devices which are collectively called agents. Okay, so interface design should include the following details. What are the details? It includes first detail, precise description of events in the environment or messages from agents to which the system must respond. The second thing is precise description of the events or messages that the system must produce. Thirdly, a specification on the data and the formats of the data coming into and going out of the system. And lastly, a specification of the ordering and timing relationship between incoming events or messages and the outgoing events or outputs. So, what is interface design? You can say that interface design is the specification of interaction between a system and its environment. Okay, and it is treated as a black box. Okay, so this is important thing. The second interface uh, the second is architectural design. Architectural design is the specification of the major components of a system, the responsibilities, properties, interfaces, and relationships and interactions between them. So, architectural design is very much important. It provides the specification of the all major systems, major components of a system, and architectural design is the highest abstraction version of the system. Understand this thing, that it provides the highest abstraction of the uh, abstract abstract version of the system. There are some issues also, like gross decomposition of the system into major components. Okay, so this is the major issue. Second is allocation of functional responsibilities to components. How to allocate the functional responsibilities to the components, and how what level of interface component interfaces to be developed. Then component scaling and performance properties, resource consumption properties, reliability properties. These are the issues in architectural design. Okay, then communication and interaction between component is a major issue when you are doing the architectural design. The architectural design adds important detail ignored during the interface design. Design of the internals of the major component is ignored until the last phase of the design. So these are the issues which we are facing during the architectural design process. Let us discuss about the detailed design. Design is the specification of the internal elements of the major component, system component, their properties, relationships, processing, and other algorithms and the data structure. So you can say that detailed design is the specification of the internal elements of the major system components. Okay, detailed design fills in all the design specifications, okay, related to the architectural design and other designing standards. So detailed design should include the decomposition of major system components into program units, then allocation of functional responsibilities to unit. So you can see here what are the issues untouched in the architectural design: allocation of functional responsibilities to component, and what are the solution provided in of this issue into detailed design. Detailed design may include the allocation of functional responsibilities to units. Then it establishes the user interfaces, unit states and state changes, then data and control interaction between units, data packaging and implementation, including issues of scope and visibility of program element, then algorithms and data structures. So you can say that detailed design provides a wide range of details because there is usually quite a lot to fill in between the architecture and the code. Okay, so detailed design means itself a detailed description about everything. Now uh, come to the next agenda, that is software design process failures and remedies. What are the failures? There are basically three types of software design failure. First is non-conformance to user needs and design limitations. Second is inadequate design document. And third is workable but poor design. So what is non-conformance to user needs and design constraints? Probably the most frequent software design process failures to a design for a system that does not meet the customer's needs. Okay, so a poor analysis during the poor analysis or failure in the proper analysis uh, uh, may cause this non-conformance to user needs and design limitations. So a designer should be aware of user needs completely. It confirms the user needs completely from the user, end user, organization, client organization, and identify the design limits. Okay, what is the remedy of this problem? The analysis method, tools, and uh, quality assurance techniques will help to prevent this sort of failure. Okay, so you should adopt the quality assurance technique. You should adopt some automation tools. You should you should adopt the analysis frequent or quality analysis methods so that uh, you can aware of the design limits, design constraints, and non-conformance to user related problems. Okay, second is inadequate design document. Many systems have no design documentation at all, and many more have only the outlines of the design or worst design documentation that does not describe the actual design of the system. So it is again a failure, you can say, the failure of the design process. And its recent advancement in design notations and computer aided software engineering tools, you can easily uh, make a, you are able nowadays you are able to make easily the design document, a quality design document. Okay, with the help of software engineering, uh, computer-aided software engineering tools, case tools. Okay, so a poor documentation provides you a poor design. Uh, Use of case tools will provide you a best design document. Okay, and next failure is workable but poor design. Workable. Sometimes this is another cause of system failure, because another design failure is a design that is less efficient, uh, robust, or understable than uh, it could be. That is a workable but poor design. So no design is ever perfect, we know, but many designs are terrible. So don't make poor designs. Use all design strategies. Use the designing process properly. Use the software engineering related tools when you are going to design a software. Okay, so uh, these are the remedies to remedies for the system software design process failure, like workable poor design solution. Sometimes a designer is not trained in some tools, in the use of some tools, or he is not able to uh, solve the uh, design related problem properly, because he is not skilled. He is never uh, saw such type of problems. Okay, and or such type of problems or particular type of problem is not encountered earlier uh, by the designer. So to the designer, so uh, if such type of problem occur, then he should be he should get the training before designing a software solution. Okay, so these are some software design process failures, and I elaborated some remedies also. Now come to the uh, last agenda of this lecture. What is good design and what is bad design? A software design process often has two levels, one of which determines the modules of the system, their specifications, and their interrelationship, and this is known as elaborate design or logic design, decides the module's internal design. A design methodology is a systematic method that creates a design by applying a set of techniques and guidelines. Most design practices focuses on system design and differentiate of good and bad design against its key characteristic is provided in the given table. Like you can divide you as you saw in the illustration in the table. There are several characteristics of a design, like change, logic, nature, cost, link, and extension. A good design consists of what? In the case of change characteristic, change is one part of the system, does not always require a change in another part of the system. So, in the good design, when we are changing a property of one component, one part, then it will not affect to the second part. And in the bad design, it is affected to the it will affect to the uh, all parts of the or some specific part of the software. As far as logic is concerned, every piece of logic has one of one and one home, and logic has to be duplicated in the bad design. So logic is unique. Every piece of logic is unique in the good design, and it has to be duplicated in the case of bad design. The nature of the project, nature of the design, good design is very simple, but the badly designed software is complex in nature. The cost of a good design, due to the good designing practices, the cost of the software will be small, but due to the bad designing, it will be very high. And the link, as far as the link is concerned, the logic link can easily be found in the case of good design, and the logic link cannot be remembered in the bad design. Systems can be expanded with changes in only one place, so extension is possible, uh, but in the good design, but extension is not possible easily in the bad design. So this is a differentiation between the good design and the bad design. This is all about the designing fundamentals. Uh, in the next class, we will discuss about the modularity and coupling and cohesion. Uh, Now this is the time for assessment through multiple choice questions. Let us discuss the multiple choice questions. The first question, software design yield dash levels of results. So software design yields three levels of results. First is architectural design, second is high level design, and third is detailed design. So what is the design yield? Three yields three levels of results. Okay, the answer is B. Which of the following is not an advantage of modularization? First is A is smaller components are easier to maintain. Second, concurrent execution can be made possible. Third, program cannot be divided based on functional aspects. And fourth, desired level of abstraction can be brought in the program. The answer is program cannot be divided based on functional aspects, because functional aspect is not an advantage of modularization. Okay, so answer is C. The third question, in design phase, which is the primary area of concern? A. Architecture, B. Data, C. Interface, and D. All of the above. The answer is all of the above, because part of the design phase is to create structural and behavioral models of the system, which is covered by architecture, data, and the interface of the product. So the right answer is all of the above. In the next question, which of these are the various techniques to generate design alternatives? Determine functional component, determine component based quality attributes. C option is modify an existing architecture, and D is all of the mentioned. The answer is D, because all of the mentioned options are the various techniques to generate design alternatives. Okay, so determine functional components, determine components based quality attributes, and modify an existing architecture. All are the various techniques to generate design alternatives. The fifth question, functional components for a working model can be stated as much as which of the following? First, configuring process startup, providing user interface, allowing user to monitor and repair the system, and all of the mentioned. All of the mention is, I think, the right correct answer. Configuring startup, process startup, providing user interface, and allowing user to monitor and repair the system. The next question, the non-functional component consists of what? Reusability, adaptability, reliability, and none, all of the mentioned. So again, the answer is all of the mentioned, because non-functional component consists of reusability and adaptability and reliability. Then in the seventh question, which among these are the methods to improve software architecture? Combine alternatives is the first option. Second is impose an architectural style. Third is apply a mid-level design pattern. And D, all of the mentioned. So again, what is the answer? All of the mentioned. Because methods to improve uh, uh, software architecture includes all of the mentioned. In the eighth question, which among these signifies applying mid-level design pattern? The first option is the best features of two or more design alternatives which can be combined into a improved design. Second is the approximate particular style may be improved by modifying them to fit the style exactly. The third option is C is the architectural style applies at low level of abstraction, and D is none of the mentioned. So the answer is C. Applying mid-level design pattern signifies the architectural styles applied at low level of abstraction. So the right answer is C. In the ninth question, what is incorrect about structural design? The first option is structural design introduced notations and heuristics. Second is architectural design emphasize on uh, procedural decomposition. C is the advantage is data flow representation, and D is it flows structured charts. The right answer is C. The advantage is data flow presentation. So, uh, in the next question and last question, what is the solution for structural design? The specification options are the specification model following data flow diagram, and second is procedural procedures represented as bubbles. Thirdly, a specification model is a structure chart showing procedure calling hierarchy and flow of data in and out of procedure. And last one is emphasizing procedural decomposition. So the answer is specific. It is a solution to central problem. Rest other are problems. So the answer is C. The specification model is a structure chart showing procedure, calling hierarchy, and flow of data in the out of procedure. So the right answer is C, uh, because uh, this is the solution, and other options are the problems. Okay, so this is all for today, and if you have any query, then please uh, consult with these reference books, and hope your query will be resolved uh, through the these study of these books. And I hope this lecture provides you a clear cut understanding about the topic that we have chosen for today. That's all from my side. Thank you very much. Have a good day.